Okay, hello everybody and welcome to our first trial of a video lesson made especially for St Anne's Year 10s. The topic we have chosen today is circle theorems. Now this is a topic that none of you have done. This is a topic that traditionally is known as a higher tier topic, but about 90% of what we are going to cover today in the first lesson will be suitable for everybody on foundation tier and higher tier. The lesson is going to be split up into 3 sections. Part 1 will be some recap questions. Part 2, I will explain and introduce some of the circle theorems. And then part 3, we will take you through 2 problem solving questions. Okay. Part 1. 4 question starter, recap. We want you to have a go at these questions. We want you to spend about 5 minutes on these questions. It's ideal if you can do these questions because that's going to save some energy in your brains for later on when you really need to use that. However, if you don't know any of the questions, that's not a problem because we will show you the solutions shortly and we will explain anything in there that's going to help you later on in the lesson. Okay, about 5 minutes, pause the video, off you go. Okay, here are your solutions to the 4 recap questions. I'm going to talk about these very briefly, just highlight the key points of revision that you really need for the rest of this lesson. So, first question was an isosceles triangle. We knew that because of this notation here. So we knew these should be equal, and all 3 of them need to add up to 180 degrees. Same thing over here. These 2 must be equal. Now down here, this might have caught some people out. All we were looking for here is just to test your knowledge of the notation behind angles. That's going to be important later on. So BNA, we can get that by doing BNA. That makes 113 degrees there. That was already given to you. ONA, start at O to M to A. That one is 67 degrees. Just a reminder there that those 2 angles are on a straight line, so they add up to 180 degrees. That's going to be important later on as well. And finally, for this question you needed to use Pythagoras. You should know this because you've got a right angle triangle and you've got 2 side lengths given to you and a missing side length. That's how you work it out. If anybody started to use trigonometry or SOHCAHTOA for that question, then you've done it wrong. That's only when we've got angles in the triangle as well as the right angle. Here we've only got side lengths. Okay? Alright, let's get on with the main part of the lesson. Part 2. This is the bit where we're going to introduce the circle theorems to you. So, a circle theorem is basically just facts about circles, and once we know these facts and we learn these facts, we can use them to help us to solve mathematical problems. Okay, so in total we've got 8 circle theorems. In today's lesson we are just going to look at the first 3. Right, before we do that, we're just going to have to remind ourselves about some parts of the circle. So this little section is really good for students on foundation tier and on higher tier. Okay, the 3 parts of the circle that we're going to look at are going to be a radius, a tangent and a chord. Okay, so the first one, radius. A radius is the distance between the centre of the circle and the circumference of the circle. Really key thing to know for the rest of this lesson is that you've got a radius here, you've got a radius there, you've got a radius there. Doesn't matter how many you've got, they're always going to be equal in length. Okay, the next we've got is a tangent. So the tangent is a line that just touches a part of the circle. Doesn't have to be at the top, it could happen down here, it could happen here, it could happen here, it could happen here. And the third thing is a chord. So a chord goes from one part of the circumference to another part of the circumference without touching the centre of the circle. Okay? Right, mini task for you to do now. What I want you to do, I want you to get a circle, draw it freehand, it doesn't matter whether it's perfect or not. I want you to get a point on that circle, down here. I want you to call it A. And from point A, I want you to draw a radius, a tangent, and a chord. Off you go. Okay, so there's your solutions. Let's make sure your radius, please, is coming from the centre of your circle. Your chord has to go from one end to the other, and it does not go through the centre. If that's going through the centre, you've drawn a diameter. Tangent, because we chose point A down here, your tangent will be from there to there. It has to be from there to there. It could not come from here now, because it's just got to touch the circle and then continue. Okay? Okay, so now we are ready to look at the 8 circle theorems. Remember, today we are just going to look at the first 3 circle theorems. Okay. Number 1. I'm going to call this the tangent radius theorem. Just going to take a tangent and a radius from the centre. And what we need to know is that where these two meet, this makes a right angle. That's it. Now that's a right angle, so is that one there, because 2 90s make 180 degrees. Number 2, we're going to call this one the chord radius theorem. Just so you're aware, these circle theorems have proper names, and at some point we will teach you the proper names and we'll teach you the right way to describe these circle theorems, but for now we think it's important that we just use these little nicknames to help us remember. Okay, so for this one we're going to need a chord. Let's go from down here to over there, and I'm going to get a radius that bisects the chord. Now what that means is that it's cut the chord in half. So I'm going to show that using these little notations here. And what we need to know is that this angle here will be a right angle. So this one here, and this one here. 490 is making 360 degrees around the point. Okay, so there's 2 of them. You will notice the usefulness of this circle theorem. If I was to make this into a triangle now, there's lots of maths behind right angle triangles that I could use to help me solve some more math problems, and the same here with this one as well. Okay, we're going to call the third one 2 tangents. I'm going to start from out here. I'm going to draw a tangent to the top part of the circle, and I'm going to draw a tangent from the same point to just touching the bottom part of the circle there. I'm going to label these points. I'm going to call this A. I'm going to call the point where they touch their B and the point where they touch their C. And what you need to know from this is that the distance from A to B is the same as the distance from A to C. And show that using these bits of notation here. So this will come in handy later on in maths, when if we were to draw 2 radiuses in here now, there and there, you would have a kite shape. There's lots of maths that you can do around the kite shapes as well. Okay, there's your 3 circle theorems for today. On to some problem solving. Okay, we have 3 problem solving questions for you. This is the first of the 3, and the question is hidden. We're going to reveal the question in a minute. What we want you to do first is just looking at the diagram, which of the 3 circle theorems that we've talked about are you going to be able to apply to this problem here? Okay, that's your time up. Hopefully you realise that the theorem that we're going to use here is the chord radius theorem. We have a chord AB, We have lots of radiuses, or radii, but the important one here is this one, which we can see bisects the chord, shown by these bits of notation here. So the important bit that we're going to use is that this here is a right angle. Okay, we're ready to see the question, we're ready to see more information and put it in there. Okay, so we are told that OA equals 12. Let's put that on the diagram. And we are also told that AB equals 15. AB is this length here, and we've already discussed that M is halfway between A and B, so this will be 7.5. Hopefully now you should be able to see, piecing things together from this lesson, how you're going to get to the solution to this question. We are looking for the length of OM. So hopefully you've spotted it. We have a right angle triangle. You're going to use, from your starter, Pythagoras to work out the length of OM. I'm going to reveal the answers shortly. I'm not going to take you through the solutions to this. If you need support, you can just drop us an email. You should be able to do this from your prior knowledge and from the starters. Okay, when I did it on my calculator, I got 87.75. The question asks for 1 decimal place, so that is why I have approximated this to 87.8. Okay, here is your second problem solving question. Again, there is no information just yet, we've just got a diagram. We want you to just see, from the 3 circle theorems that you've learned today, which ones could we apply to this question. 30 seconds, off you go. Okay, so hopefully some of the things that you've spotted about this question then, we have got a radius here, here and here, which will all be equal in length. That's going to be important. But really key point here is that PQO is going to be a right angle, and that comes from your tangent radius theorem. Okay. Okay, let's get some more information. Okay, the top line, yeah, I think we kind of knew that already. This is going to be the information that we are now going to put into the diagram. So just have a think where that's going to go. Angle OPQ. It's 28 degrees. OPQ. Let's get that in here. Now, I'm not going to give you a question to this one. From that point there, I want you to just work out as many angles in that diagram as you possibly can using the information from this lesson. I'm going to give you 2 minutes. Off you go. Okay, there are the solutions. There were 4 other angles that we found. You may have found more than that. If you did, fantastic. So just to summarise, we knew that this was 90, so from this triangle here, this would be 62. Here we've got angles on a straight line, so we can work out this angle here. And really important, and well done if you spotted that we've got 2 radii equal in length, shown by these notations here. So these 2 angles will have been the same, these 3 making 180. Well done. Okay, thanks everybody for taking part in our first ever lesson, our first ever video lesson. We're really interested to hear your feedback so we can try and make it better next time we do it. And just so you're all aware, this lesson was based around tasks on active learn, so every single one of you has now been set a task on Active Learn called Circle Theorems 1. We look forward to seeing how you get on with that. Thank you very much.